All right, so the first thing you got to do is turn on your diagnostics. So I press mode, and yeah, and then you just go down to, keep going down to the next page, and when you get to stat or the diagnostics, highlight that. All right. So what we're doing here is we're finding out the age of your age of your tires affects your gas mileage. Okay, so the older your tires are, your gas mileage goes down. All right, so for example, if you had tires that were 1 year old, then you'd be getting, in this particular case, 20 kilometers per liter. Okay, by the time your tires are 6 years old, you'd be getting only 13.2 kilometers per liter. Okay, so when we're doing these guys, this is L1, this is L2, and when you type this in, before you type it in here, let's see, view in front. Okay. Later on, you're going to have to be writing down what the constant value means and what the regression line, or what the slope means. All right, so when I do the constant value, that's the same as the y-intercept. Okay, so when we get to this part right here, what's the meaning of the constant value? The constant value is your fuel economy. Keep that in mind. That's in kilometers per gallon. Okay, so that's the constant value, fuel economy. Kilometers per liter, I'm sorry. Okay, now the X is the age. Okay, so when we do the gradient, okay, gradient is y over x. So that's going to be the kilometers per liter per year. So when we, later on, because that's what you're doing on your assignment today, is you have to write down what the meaning of the gradient is and what the meaning of the x-intercept is. So you got to know what those are. So for example, if we were doing this problem right here, if you turn to 7D, or yeah, all right, you got 35 minus this. Okay, so the gradient in this case is 5/10, and the y-intercept in this case is 35. And now you got to say, well, what are those? Oranges, apples, miles, kilometers. Okay, so if you look at the equation here, it says a school principal collected data on the number of days per year. That's X. So this is the number of days per year that various students spend playing sports. Per year playing sports. All right, so the y is equal to the number of hours of homework and the number of hours of homework they do per week. So this is number of hours of homework per week. All right. So now you got to figure out, well, what do these things mean? Okay, so if we look at the gradient, okay, I could take this and put it over 1. Okay, now the top number is the y and the bottom number are the x's. So this would be hours of homework per week, and this would be 1 day of playing sports. How about, can you wait a second here? Yeah. All right, now once you see that, you can kind of put this into a sentence. For every day of playing sports, you get a half-hour homework. Or you could write a half-hour of homework for every day playing sports. So in other words, okay, 0.5 hours of weekly homework per 1 day playing sports. And that's the meaning. Now the 35, that's the y-intercept. So this is the point 0, 35. So this means if you don't play any sports, okay, you're going to be doing around 35 hours of homework a week. So that's what you're doing on these. So that's why you got to understand what the x and the y are. Okay, so when you're working through these and you're doing the gradient or the slope, this is the y and that's the x. And then when you're doing the y-intercept, okay, the x is 0, and that's whatever, this is whatever the y-intercept is. That's the y. So you can use the labels. Okay? All right, so keep that in mind when you're doing these other two here. Okay, now back to this. All right, so first thing is put those in L1 and L2. So clear out those lists. Clear. And then type in your X's and your Y's. So age, these are how old your tires are. And then how many kilometers you're getting a gallon. All right. So we just did this part. We just did this part. Okay, now to get our regression equation, Okay, there's part right here. So you're going to go stat, calculate, okay, number 4, linear regression. Enter. Okay, now here's where something's going to be new. Okay, all right, so you got the correct lists. You don't have to change anything there. But what we want to do now is we're going to store the equation, and we're going to store it in a place called y1 so that we can graph it. So when we're done, what your equation is going to show up, let me just show you. Your equation is going to show up right on this page right here when you're done. So we want to put it there. Okay, so to do that, okay, so let's see, go back, 4, enter. There is no frequency list. Okay, here's how you put y1 there. Okay, you're going to press the key that says VARS, variables. Okay. Then you're going to do the right arrow, and then you're going to choose enter 2 times. So I'm going to go enter, and see how it's already highlighted y1, enter, and there it is. So that's how you store it in y1. Right? Then you go down and you hit calculate. Okay? So now, to get our regression equation, y equals 3.14x, and b is 21.3 if we round it at 3 sig figs. All right, now the constant, this is the y value when x is 0. So the constant is this. Now, what does that mean? Well, X is the age of your tires, and Y was your fuel economy in kilometers per hour. So when your tires are new, you're going to get 21.3 kilometers per hour. Oh, kilometers per liter. So when your tires have an age of 0, they're brand new, that's when you get your best fuel economy. And if you look, it's a pretty good fit. The R value is negative 0.997. That's pretty good. That's a strong negative relationship. Okay, now the gradient. That's the slope. Okay, so our slope is the y over x. Y was kilometers per liter, and x was the years. Okay, so what does this mean if you get a slope of negative 0.134? Pardon me? No. What's? It's asking what's the meaning. What's happening to your gas mileage for every age, for every year of tire age? Yeah. So your fuel economy decreases 1.34 kilometers per liter for every year. So for every year, it goes down through 1.34 kilometers per year. Okay, now the last part is it says use the regression equation, the equation of regression, to estimate the distance the car would travel on 1 liter of diesel when the tires are 3.5 years old. Okay, so if we did a graph here, let's see, 1, 2, 3, 4. That's going to tell us this is going to be the fuel economy right here in kilometers per liter. All right, now to put your graph on there, let me do it. Okay, so we've got all this in there. Here's the keystrokes to get your graph to show up. So you go second. Okay, y equals. Okay, you're going to turn on your plot. So plot 1, just if it's off, you got to turn it on. So mine's already on. Scatter plot L1, L2. Okay, now to graph it, you press zoom 9. Zoom 9. And it should graph your scatter plot. And the line that it just graphed is your equation. So your equation is in Y1. You can't see all of it because the numbers are really long. But if you scroll over, there's the rest of the equation. It's in there, it's just really long. All right, now what we want to do is we want to plug 3.5 in for x. So we can have the calculator do it. Okay, so to figure out this question, we're going to take this and substitute it in for x. So if we took this equation right here and we took that out and we put 3.5 in. But we're going to I'll show you how to do it on the calculator so that you're not using rounded numbers. Okay, so if you plugged it into this equation, your answer is going to have a little bit of error in it because you rounded numbers. All right, so to avoid that, you can do this. We want to plug it into this equation. Okay, so here's how you do it. You're going to press variables. So go second, quit, get to your home screen. So I just did this. Now, variables, right arrow, Enter, enter. Okay, now put in that decimal. Parenthesis, 3.5. And now it's going to plug that 3.5 into that long version. And hit enter. So what this does here, it puts the 3.5 in the stored version of your equation. Then you round your answer. Okay? And so the distance you would travel on 1 liter would be 15.6 kilometers. Okay? So what this does right here, guys, is just substitutes in, plugs 3.5 in for x. That's what that part does. All right, so that's what you're doing on number 4 here. You're going to do number 4 just like the one we just did. Yeah, go ahead. Yeah.
Oh, yeah.
It's what? 9? It's time to go? Okay, see ya. Where are we going?
We're leaving.
We're not going, there is no, whatchamacallit? I don't know either. Ask Carlin. Anybody else leaving? Ask Carlin if there's a celebration. I don't see any movement out there.
Government celebration. Me too. Everyone.
I read my email. No celebration? Right. No, but I do like quiet. Not that it's that noisy in here.